Hello everyone, welcome back to the machine learning videos and lectures. In today's lecture, I'm gonna make a brief tutorial on another library in Python that is Matplotlib, this library. And this Matplotlib is used to plot some diagrams, just like some commonly used softwares you used for plotting diagrams, such as Excel, arranging, and something like that. And this one, if you use this Matplotlib library to plot your diagram, you don't need to install any software. You just need to run Python and import this library, and you can plot your diagram. So it's very convenient. And here, let me firstly uh, type the title here. So this would be lecture 12. And this one, we will make some Matplotlib tutorial. I have to point out that this library is very powerful. It can plot almost all the diagram you want. So this video is just a brief tutorial. Each time you want to plot something and you don't know the code, you just need to Google it every time. I will just cover a very small part of this library, and actually it's very powerful. So next time you want to use it, and when you don't know how to code, and you just need to Google those parts so you can know the answers from Google. And firstly, I want to say something about some other softwares or tools that you may have used to plot the curves and diagrams. So some commonly used tools or softwares to plot diagram. Okay, maybe the first one that will come to your mind is a very simple one, maybe Excel. You can use Excel to plot your diagram and curves, of course. Excel is very powerful. And I think the advantage of using Excel to plot your diagram is that it's convenient and it's quick. You just need several columns of your data, and you click on plot and you will get the curve. And the disadvantage of Excel is that if you want very beautiful diagrams or curves to put in your paper, and it may take you longer time if you want some uh, beautiful plotting from Excel. Okay, and the second plotting software that I have also used is Origin. And this software is is similar to Excel, but it's I think it's better than Excel because you can draw some very beautiful diagram or curves by using Origin. And but I think the disadvantage of using Origin is also that if you have very large number of data, and if you use Origin to plot that, it may make your computer very slow. And also, if you need to change your data and get another curve, may be not that convenient by using Origin. Okay, and for these two, you don't need to code. You don't need the coding to plot the diagram. You just use the GUI. You just uh, use the computer and human interface. You just need to click on the software and you get the curve. You don't need to do the coding. And for the third one is that, of course, you can use MATLAB to do the plot, and it's also very convenient. And the last one would be this one we are talking about, would be using Python. Specifically, use the Matplotlib, this library. This is actually a library. And the same thing about the Matlab and Matplotlib is that they are based on coding. So you need to code something to get your diagram. And another advantage is that because you have the code, if your data is changed, you don't need to change your code. You just need to change your data. So MATLAB and Python is more powerful when your data is very large, or you need have to change your data very frequently. But the plot is not changed. You just need to change your data. So in this case, it would be more efficient to use MATLAB or Matplotlib. So under these circumstances, if you are still using Excel or arranging, it may be the efficiency would be lower. So that's something about these softwares to get some diagrams. Okay, now let's start the tutorial on this Matplotlib library. If you want to use it, you don't need to install any software. You just need to open Python, and you just need to import the Matplotlib and there is a py plot. And because this name is very long, we will give it a new name. We usually give it a name as plt. Okay. And I will import the NumPy because I will be using it to create our data. This is something we have covered in the last video here. Okay. If you type this, you need to run this cell. And if you run it, these libraries would be successfully imported. And then let's start doing the joins here. Let's firstly create the data. Suppose we want to create a sinusoid. It's very simple. It's just a sinusoid. We need firstly create the x-axis, that is the horizontal axis. Okay, we will do something like this. We will use the NumPy library, and we will use the linspace. So you remember what we are doing here in linspace. Suppose we are doing, we start the 1D array from 0, and we goes to 4 pi. Let's say we goes to 4 pi. So it's 4. We will use numpy dot pi. So this one will give us the pi, and we will. So this is the start value. This is the ending value. And you should tell our NumPy that how many points you need between this range, in this range. So let's suppose, let's create 1,000 elements in these 1,000 elements, 1,000 numbers in this range. Okay, this would be our x-axis, and for y-axis, it's a sinusoid. So if you want to use sinusoid, you cannot type this sign directly like in MATLAB. You need to use the NumPy. Okay, and NumPy will give you some functions, and let's do the sinusoid on this x. Okay, if you run it, this would be successfully run. And let's plot the diagram now, because we have the x-axis and we have the y-axis. So now we are able to plot the joins. Okay, if you want to plot it, because we have imported this as plt, so you just need to call plt dot plot and bracket and x. So you should put the horizontal axis first and then vertical axis y. Okay, if we run it, you can see you will get a diagram like this. So we have successfully got a diagram like this. But you can see this diagram is too simple. This color is not beautiful, and we have no labels of the y-axis. We don't have the labels for x-axis either, and we don't have legend here. So let's do something to make this diagram more beautiful. Okay. Firstly, if you want to change the color and the line width of this curve. You can plot more. You can do some code more in this plot. After x and y, you can see that the line width you want maybe is 2. This would set the line width of this curve, and maybe a color. You want to change the color, you just call color, and you use the quotation and to give you red. Okay, this R represents red, and if you want some other color here, you can Google the color index of this Matplotlib, and everything is on Google. And of course, you can change the color to whatever you want. And let's see if we want to give this curve a label. You can just give it at here. And let's say this is a sinusoid function. Okay. Okay. If you run this, you can see that this curve, the color is changed to red, and this line width is thicker now. If you change it to a bigger number, you can see this curve is getting thicker. Okay, we will just use one. We didn't see this label because this one is for plotting the curve. We didn't call the legend code, so here we didn't see this, and we will see this later. Okay, if you want to give this diagram a title, you just plt dot title, and you give it a title. Also, maybe I give this title sinusoid. Okay, if you run this again, you can see there is a title here. This is sinusoid. Okay. If we want to add the label for the y-axis and x-axis, we can do some code like this, plt dot x label. So this would set our x label here. Okay, our x label would be the angular frequency. Okay, and for our y-axis label, I just copy it, and it would be amplitude, of course. Okay, if you do this and you run it again, you can see we have the axis labels here. You just type it here. Okay, let's do more. Let's set the axis. So you can see now the axis. If we want to change the line width of the axis, or if we want to change the direction of these ticks, you can see now the direction of the ticks is outward. What if we want to change it to inward? We can do something like this. Okay, this is for setting the axis. Okay, and firstly we will set the x-axis as ax. So this is, you will firstly need to define plt dot gca. So this would so this means you will be setting the axis, and then you just call x dot spins top. So this one means you will be setting the line width, the property of the axis, top axis. That is this line. Okay, this is this line. Okay, if you and dot, let's say set line width. Okay, then you can set your line width. For example, I set it to 2. If you run it, you can see this line goes to thicker. And of course, you can just copy this code, and you just want all these axes the same line width. Okay, you just need to change it to maybe this one, change it to bottom, and also this one you change it to left. This one you change it to right. So this covers all these 4 axes and change their line width to 2. We can see if you run it, all those line width of these 4 axes is changed to 2 here. Okay, And now we can see the ticks is not good. The weight of these ticks is too small, and it is outward. I want it to be inward. So I can do something like this. Also x dot tick, this one tick paris, that is tick parameters, and we use a bracket here, and we set the direction. Firstly, direction equals to in. So this one would means that I will set the tick's direction to be inward, and then you can set the length of the ticks. So the length of the ticks is this height. Let's say we change it to 8, and also you can set the weight of these ticks to be maybe 2. If you run, you can see that this ticks goes to inward, and it is thicker and it is longer because it set the length to be 8. So if you change it to maybe 16, you can see it goes to even longer, but we don't need this long. Maybe we can use it as 6. You can change it to whatever you want. Okay, so now you can see our diagram gets nicer, but it's not nice enough. So we can see our x-axis, the limits of our x-axis is not exactly from 0, and also the y-axis is not from exactly -1. So we want to set these limits. So we can do something like this. We'll also use PLT, just the x limit. Okay, so this is for setting the limitation of the x-axis, and you just use. We can see now it's from 0 to 12. Maybe we can set it to be 0 to 14. Also the y-axis limitation. So it's -1 to 1. Maybe we can use -2 to 2. Okay, so you can see now this limitation makes more sense now. Okay, and we don't have legend here, although we have set the label, but we didn't call our legend to come out. And if you want the legend, you will do something like plt dot legend. This will call out. This will plot out the legend. And firstly, you want its location to be. There's many location parameters. You can put it on this top right, or top left, or bottom right, bottom left. You will have different parameters. And for the more convenient one, you can just say to put it to be in the best position. So you just put best here. And if you type frame on, okay, so let's firstly see what this will give up. So you can see if I use this line of code, so this one, this legend is exactly the label here. Okay, if you don't want this outer box, you can just add the frame on and let it to be false. So if you do this, oh, I don't need the quotation here. Okay, if you do this, you will see that this legend will not have the outer limit or the box. So it will no longer have the frame outside of this legend. Okay, if you change it to true, this is by default. If you change it to true, so this is the default. You will have the frame of this legend. Okay, and let's continue. So so we can see that this diagram, the size of this diagram is too small, and maybe we want some bigger diagram, and we can also see that all these all these all these the font style or the font size is too small. The font size is small. We cannot see the numbers maybe very well, and the font style is not what we want. Maybe we want the font style to be usually the Times New Roman. So how can we do that? I can maybe I want to change the font style as the Times New Roman. I want to change the font style for all of them. And also I want to change the font size uh, for all of these numbers and these labels here. How can we do that? Is that we can import something more here. Instead, we can let me import the Matplotlib again, but this time as MPL. But this time I just import it all as MPL, and I will also from this I will import another library from this Matplotlib library that is from this, and I will import RC parents. Okay, I will import this function. So you need to run this cell, and I will do something like this to change the font size and font style to Times New Roman. And firstly, I will make this plot bigger. I will make this plot size bigger. So I will use also plt dot figure. So this is to set up the figure, and I will use fig size equals. Okay, this is for setting the size of this figure. So this is the 20 would be the size in the horizontal direction, and 10 is in the vertical direction. Okay, if I just add this line, if I run it, you can see our diagram goes bigger. Okay, if you can also change it to 40. Let's see what happened. Okay, it goes to like a rectangular shape because this 40 in this horizontal direction is much bigger than this 10. But we can see that if we increase the size of this figure, all these fonts are too small. So we cannot see them. So we need larger font size here. Don't worry, we can do something like this because we have imported this one. We will use this RC parent. Okay, plt dot RC this one parent and update. So I will change the font size here. Okay, I will use another bracket here and the quotation here and say font dot size and column. So this is for setting up the font size. I set the font size to be 40. So this one now is very small. Okay, let's run this cell. Okay, you can see if I set the font size to be 40, all those font size, including the labels and the numbers, all goes to 40 here. You can make it bigger, 60, but this is maybe too big. Okay, we just use 40 here. Okay, so now next we are going to set the font style. We want the Times New Roman. Okay, we can do something like this. MPL is this one, MPL dot RC and quotation font, and we will use a family. So the family of the font would be Times New Roman. Times New Roman. Okay, this will set the global font style. The global font style means this font style will be applied to all the numbers and all the labels and the titles here. Okay, let's try. So you can see now our font style is changed to Times New Roman, including the numbers and including the labels here. So this diagram would be much nicer than before. Okay, we can see this maybe the line width of this one is small. Maybe we can change it to 4. So this line is thicker now. Okay, and maybe you can see that these two numbers is a little bit overlapped with each other. So if you want to move these tick labels a little bit farther away from each other, we can do some code like this: x dot tick Paris and axis, because we will set the x-axis first and we will use pad. So pad will move the labels of the ticks farther away from the axis. I set it to be 15. And also, I do the same thing for y ticks, and this is for y. Also, pad 15. So if we run, we can see these two numbers are not overlapped with each other anymore. Okay, so we can see that we start with a very simple diagram like this. I will plot it out again. So we start with a very simple diagram like this, and we make it more beautiful to a diagram like this by using this code. The benefit of using this code is that if you change the data and you don't want to change the style, you just need to change some code here, and all those codes stay the same. So it would be powerful when you have different data, but the style should remain the same. Okay, if you want to use this diagram in your paper, you just need to right click and use a copy image, and it will copy this image for you. Also, of course you can save this image, and you can also save this image by some coding. Okay, and this will save this image to your desktop. Okay, I think that's all I want to cover in this lecture on this library. So here we have covered the different softwares and tools to pull out some diagrams. I think that's for commonly used softwares. And we have mainly focused on this Matplotlib library in Python. And this library is very powerful. It can plot any diagram we want, not just some curves. It can plot anything we want. And when you want to use it, and you don't need to remember all those codes, you can search it on Google, and Google knows everything here. Okay, I think that's all. Thank you for watching, and see you next time.